What we're going to be discussing today is the issue of lead in water as an underappreciated public health threat. The lead in water that we're concerned about is coming from one of three different sources, either lead or brass service lines that are used to connect to the houses, the lead solder, that's the metal glue used to connect two lead pipes together, or leaded brass fixtures, which are still legally installed in homes today. And just to give you a visual presentation of what each of these sources looks like, this is an example of what lead solder looks like on the outside of the pipe. You can only imagine what it looks like on the inside. This is a picture of a cutaway of lead service lines from Washington, D.C. that I obtained from Mike Schock. And these are 100% lead pipes, essentially, connecting these homes in the United States, about 2 million of them, to the water mains. And then there's also lead and brass right in these fixtures that are right at the end. And those can still legally contain up to 8% lead by weight. According to congressional definition, that qualifies as no lead, believe it or not. First and foremost, lead in water poses an acute human health concern to young children. Second, the way we look for lead in water is almost by design missing many of the worst lead problems that are out there. Public health officials do not understand this problem in the slightest, and if we consider the health threats from high lead in drinking water, it can explain some very perplexing findings that are in the human health literature. And as a result of this, the Consumer Product Safety Commission established 175 micrograms of lead as a dose that, if it's found in a toy or a trinket, would trigger acute health concerns, fines, and product recalls. So that's the standard that society sets. And I'm going to make a controversial assertion here that if 175 micrograms of lead in any of these products that are not designed for human consumption, that if we find that same dose of lead in a water sample, which is designed for human consumption, we should be concerned about it and take action. A dose of 175 micrograms lead is unacceptable. Well, based on Freedom of Information Act requests of various schools around the country, what you'll find is that many of these school systems have a high percentage of their schools where at least one water sample tested above this acute health threshold. In Washington, D.C., 2007, we force-released the data that showed 10% of the schools in Washington, D.C., from a single glass of water would deliver a dose exceeding 175 micrograms lead. In some of these schools, more than 80% of the taps exceeded EPA standards of 20 parts per billion. And this information was not shared with students, parents, or teachers for at least 2 years. If you look elsewhere in the country, Seattle, 4.5% of schools. Blacksburg, of course, we only had 5 schools, so it was 1 out of 5 that had this high level of lead. And if you look at these what levels we're talking about, in some cases, they're actually very, very shocking. This is a log scale, the highest sample of lead that we measured in each of these schools based on the forced release of data from the Freedom of Information Act request. Many of these samples were in the hazardous waste range for lead in water. And to put this dose into context, this is a picture of what the worst case sample looked like. A 250 mil lead in water sample measured 20,000 parts per billion from a kindergarten room in Washington, D.C. To get that same dose from lead paint, you'd have to eat about 14 dime-sized lead paint chips with 1% lead content. This is a dose from a single glass of water that's high enough to put a kid into the emergency room. The way we're sampling for many of these problems is missing the worst of the lead. So, for instance, what we're talking about here are little pieces of lead particles. Solder that's corroded, lead rust that's corroded, it's fallen off into the water. And the fact of the matter is, when the EPA designed the lead and copper rule, they largely assumed that lead in water was going to be soluble. So the protocols they developed are for soluble lead, not particulate. And this is a problem because these high levels of lead we're encountering in general are particulate. These levels of lead that pose this acute health risk. And just to give you a little cartoonish representation of what's going on, what happens is you have your lead-bearing material, you have the water flowing by it, and you've got lead solder, lead scale, or rust that's occurring. And you get flow events, and these particles get detached and into the water. And if you're drinking the water, of course, it goes right into your stomach. But if you're collecting a sample, what happens is you collect your water, the particles sink to the bottom of the sampling container, and EPA only requires a pH 2 acidification step for preservation. This is not strong enough acid to dissolve that lead in the particles. And the water, when you pour it out for analysis, you miss it completely. But when we looked at it and you consider what's going on in the human stomach, turns out you've got more aggressive acid in the human stomach. And the net result that we were able to show is that the particulate lead missed in the EPA protocol, a substantial fraction of it is bioavailable if you were to ingest it. So this missing lead does matter. Now, if lead in water was a significant health concern, wouldn't someone tell us? Wouldn't public health agencies tell us that this is something we should be worried about? After all, we're the engineers. We have responsibility for controlling this problem. I just want to summarize the CDC's current understanding of childhood lead poisoning in the various sources. First and foremost, of course, there's lead paint. And then we always have to be very concerned about lead paint. And then you got to check for the lead paint. And even if you can't find lead paint in the child's house, go back and look again, because we're virtually certain it's going to be lead paint. This is their mindset. I thought, it was just me. I thought I was the only one who saw this kind of blinder philosophy. But there was histories of the lead and copper rule where, oddly enough, the CDC was opposed to doing anything against drinking water because they thought it drew attention away from lead and paint. And this is a little bit ironic because lead and water is the one source that we control directly through a shared system of responsibility. And mitigation can be low cost through use of simple filters, flushing, and other remedial measures. And what I've learned over the years is that, frankly, these public health agencies are skewing the analysis to fit their worldview. And this is very, very shocking. It's been shocking for me to learn. So I conclude that we do a horrible job in this country of not protecting children from this rare but still significant health risk. The higher levels of lead sample in many U.S. schools exceeds thresholds that would trigger products fines and recalls if found in toys by the Consumer Product Safety Commission. There's no evidence, none whatsoever, that elevated lead in blood, lead poisoning from tap water, does not occur with fairly high frequency in some cities, and it just simply goes undetected or is covered up. We're sometimes missing the lead hazards by the way in which we sample, sometimes intentionally, sometimes unintentionally. And the public health agencies involved in this really do not understand this issue at all. And in fact, in some cases, they view it as a threat, because there is, without a doubt, a hypocritical double standard that's being applied to lead in water versus these lead in toys. And one is being touted about, and it's in the press all the time, because we can blame it on manufacturers in China, or we can blame some landlord. And here we are, lead in water is our responsibility, and we're doing nothing about it.